Okay, now we are going to do a lesson about finding the area under the curve. So what we did before with estimation, now we're going to do it with integration. Okay, so this symbol is an integral symbol, and this just is a piece where you say you're integrating with respect to what variable. Okay, and then here's that language that if this is a little f of x, this is a big F of x to mean the antiderivative. Okay, so just some language. So we're going to integrate this function with respect to x. Okay, so integration is the same idea as finding the antiderivative. Okay, so when you integrate something, if it's an indefinite integral, which you're not doing it for a specific amount, it is the exact same thing as doing an antiderivative. But if you integrate something specifically from a number 1 to a number 9 here, that is called a definite integral. Okay, so here's this question. We're going to find the area under the curve. So under the curve x squared from 1 to 9. That's what we're doing. We're finding the area under the curve from 1 to 9. Now, we did this on our first lesson right here, from 1 to 9. So here are our numbers. We had 168 when we did the left, 328. We did a 240 with the midpoints. And when we did the trapezoids, we had 248. Okay, so those were our area estimations. We knew that this was low, we knew this was high, and these were closer to what we should get. Mommy? What? Can you get my sweater up? Okay, so we're going to integrate this and find the area. Okay, so what is the antiderivative? So we would have started with a x cubed. What in the front would we need to make a 1? We would need a 1/3. Okay, so now that I've found the antiderivative, I'm going to put a square box like that, and I'm saying I'm going to evaluate it from 1 to 9. Okay, so what is the area under the curve till 9? So basically that is this whole area, and then you're going to subtract the area under the curve to 1. Okay, so you're taking that whole area and then you're going to subtract that area. That's what it's going to be doing. Okay, so 1/3 times 9 cubed, and then we're going to subtract 1/3 times 1 cubed. Okay, so 9 cubed is 243 minus 1/3. So that is the area under the curve. So you can see how actually our trapezoid is pretty close and our midpoint is pretty close to that actual number. Okay, we knew that those were low and high. Okay, we're going to find the area under this curve. So 9 minus 3x. So I do know what that looks like in a graph. That is linear. It's going to have a y-intercept of 9, and it's going to go down 3, right 1, down 3, right 1, down 3, right 1. Okay, so I want to find this area. So I'm going to find it from an x value of 0 to an x value of 3. Okay, so that is this language, finding the integral from 0 to 3 of this curve with respect to x. Okay, so I'm going to antiderive this. So this would become 9x. Okay, and this would have a squared on it. And then what would I need to counteract to make a 3? 3 halves. Okay, so now I would take this equation and I want to input a 3. Okay, and then I'm going to take that equation and input a 0, subtract the two values, and I get 13.5 as an area. This one I also could check with a geometry equation, and it's a triangle. So half times base times height, or base times height divided by 2. So this is 9, and this is 3, and if I take half of that, I get 13.5. Okay, I'm going to do this one with you. So this is the equation 6 minus the absolute value of x. So this one, I'm not going to show you with integrals, I'm going to show you with geometry. So if I do y equals x, if I just graph it, it's just your basic line, slope of 1, y-intercept of 0. If I do the absolute value of x, keep the positive, reflect that negative piece. Okay, so that's now what you can see I did up here. And now I'm going to reflect that. So this graph, I'm going to put a negative in front, so that's our reflection. And then you can see that there's a 6 on this, which makes everything higher 6 or up 6. So that's what the graph looks like now. Okay, so when I find the area under this curve from -6 to 6, that's what I'm doing. So I'm just going to use geometry. This base is 12 wide, the height is 6, so 12 times 6 divided by 2 equals an area of 36. Okay, find the area under the following function from 0 to 5. So y equals 5. So let's think about what that looks like. Y equals 5 is just a horizontal line at 5. Okay, so from 0 to 5, so if I want to find the area under the curve, it would look like that. So in geometry, I would just say that this is 5 and this is 5, so the area is therefore 25. If I want to use calculus, I'm going to say the area is the integral from 0 to 5 of the function 5 with respect to x. How do you find the antiderivative of 5? It would be 5x. So you would evaluate it from 0 to 5. So now you input the higher limit, so 5 times 5. Subtract and input the lower limit. So 25 minus 0 equals an area of 25. Okay, so here we go. We're going to find the antiderivative. So x cubed, and then don't need a coefficient. This would start as an x squared, so I would need a 2 in the front. I'm going to evaluate it from 6 to 2. Okay, so plug in the upper limit. Okay, so when you plug in a 6 cubed plus 2 times 6 squared, you would get 288. Subtract and plug in a 2. And that is 16. So this, subtract this value, you get an area of 272. Okay, next. So we're going to antiderive that. So one higher, so think about 2/3, you would have to add 3/3. So 5/3 times what to get you a coefficient of 1? So 3/5. And the antiderivative of 5 is 5x. You're going to evaluate it from 1 to 4. Okay, so 3/5, 4 to the 5/3 plus 5 times 4. Okay, so there I inputted a 4, subtract. Now I'm just inputting a 1. Okay, so this is 20.0476, and this comes out to 5.6. So subtracting, you get 20.448. Okay, next one. I'm just going to rewrite this underneath. Okay, so it's easier for me to antiderive something when it's written differently. Okay, so let's find the antiderivative. This would have started as ax cubed. So what do I need in the front? And then that would get me a 1/5. So if you can't do that in your head, you just say 3 times what is 1/5. So if you divide by 3, you get 1/15. Now, 1 over x is a one function that you're just going to have to memorize. What do we derive that results in a 1 over x? And that is the ln of x. Okay, that's just what we have to memorize. So that's what that is. And we're going to evaluate that from 1 to 8. Okay, so plug in the 8. Minus, and then plug in the 1. Plug in the 8, plug in the 1, subtract the two values. So here's what you should get. Final answer is 36.146. Okay, next page. Okay, the antiderivative, you would have started with x squared, so that would need to be a 4. And 6a squared is actually all a constant. So what do you do when you have like a constant? The antiderivative would be the same thing with an x on the end. Okay, so now you're inputting an a for the x spot, and then you're inputting a 0 for the x spot. So 4a squared plus 6a squared input a. Okay, so I inputted an a. And I'm inputting a 0. Okay, so this is 4a squared plus 6a cubed. All of this is 0, so it's irrelevant. That's my final answer. Okay, last one. Okay, anti-derive this, so that starts as an x to the 4th, and then I don't need anything because I just need a 1 here. This would start as x squared, therefore I need a 4. Evaluate from 3 to 6. So 6 inputted minus 3 inputted. Okay, so when I input a 6, I get 1152, and I input a 3, I get 45. So 1107.